All right, we are taking a look at sequences today. So first I'm going to go to the definition of what a sequence is. So a sequence is a function whose domain is a set of consecutive whole numbers. So if the domain is not specified, it's understood the domain starts with 1. So when it means consecutive whole numbers, we're looking at the values 1, 2, 3, 4, 5, 6. We won't have a domain with 0. We won't have a domain with negative numbers. So it's sort of nice. We're going to be working with positive whole numbers. Our next term is terms, and terms are what we call the values in the range of a sequence. So our domain will be 1, 2, 3, 4, 5, 6. Our terms are the values of the domain. And then we'll also be looking at a rule, our next vocab word, which is the equation of a sequence. And the equation of a sequence, we looked at equations we typically see in the form y equals. For a sequence, it will be in the form a sub n equals some expression. So that's the rule of a sequence. We won't call it the equation of a sequence, we'll call it the rule of a sequence. All right, the first problem we're going to take a look at, we're first going to write the first 6 terms, and we're going to identify the domain and range. Now once again, our domain isn't specified here, so since it's not specified, we're going to start with 1. And 1 will also be our first term. So we have a plug and chug type method here. All right. So our first term we're going to indicate by a sub 1. Second term we'll indicate by a sub 2. That n value is the number of the term. So when n is 1, that's our first term. When n is 2, it's our second term. When n is 3, it's our third. When n is 4, it's our fourth term. When n is 5, it's our fifth term. And when n is 6, it is our sixth term. So to figure out what the first term is, we're going to substitute in 1 and for n. So this will equal negative 2 raised to the power of 1 plus 1, which equals negative 2 raised to the power of 2. So we have negative 2 times negative 2, which will give us positive 4. Our second term will have negative 2 raised to the power of 2 plus 1, which equals negative 2 to the third power, which equals negative 2 times negative 2, which is positive 4, times negative 2, which gives us negative 8. And when our third term, we have negative 2 raised to the power of 3 plus 1. That will equal negative 2 raised to the power of 4. So we have negative 2 times negative 2, which is positive 4, times negative 2, which is negative 8, times negative 2, which will be positive 16. And then our fourth term, we have a to the fourth equals negative 2 to the power of 4 plus 1, which equals negative 2 to the power of 5. Negative 2 to the power of 5 will be negative 32. Then we have negative 2 to the power of 5 plus 1, which equals negative 2 to the power of 6. Negative 2 to the power of negative 6 will be positive 64. Now we can, multiply them out, but if you notice, I'm just multiplying each of the previous by negative 2. And that's one thing with sequences. You will have patterns that emerge, which is a great thing about them. So our sixth term, we can use that conjecture, and we have 64 times negative 2, which will give us negative 128. All right, so those are our terms. So we need to define the domain and range. Now our domain, keep in mind, are our input values, so the values that we input into that function. And we input the values 1, 2, 3, 4, and 5, and 6. So our domain, we have 1, 2, 3, 4, 5, 6. Our range are our output values. So our outputs, we have 4, negative 8, 16, negative 32, 64, negative 128. So that is our range. And with sequences, we don't put it in numerical order. We put the range in the order that it came out. So in order of first term, second term, third, fourth, fifth, and sixth term. All right. The next thing we are going to take a look at is writing a rule or identifying a pattern for the next. We're going to find the next term and then we're going to write a rule for the nth term. So for this first sequence we're looking at, we have -1, -4, -9, -16. So when you take a look at these, you're looking for that pattern that's happening. Now I notice between the first and the second term, I decrease by 3. From my second to the third term, I decrease by 5. From the third to the next term, we decrease by -7. So I notice there's some odd values coming up there. So another way we could also take a look at this is I can rewrite this term as 1 squared. I can rewrite the next one as 2 in parentheses squared, which is negative. The next one, 3 squared, but it's negative. And the next one, 4 squared, but it's negative. So I can use that to sort of digress, to sort of take a step back from here. So the pattern for this one being squaring the input and then multiplying by -1. So that's a fine description there. So to write the next term, so my next term, we went 1, 2, 3, 4, so our next term will be 5 squared, but then we're negating it, so that will equal -25, so my next term would be -25. And the rule there